formula. So 1 by 2 pi j integration over c e power z dz by z minus 2, which is compared with integration over c f of z dz by z minus a. And by Cauchy's integral formula, answer for the integration is 2 pi j into f of a. Now by comparison, my f of z value is e power z and a value is 2. So if f of z value is e power z, your f of a value, that is f of 2, is e power 2. Okay, right? So therefore I will get 1 by 2 pi j into 2 pi j into f of a. 2 pi j and 2 pi j gets cancelled. So answer for the integration is simply f of a. And we know that f of z is e power z and a value is 2. So therefore we are going to find what is the function value at the point z equals 2. So that is f of 2 equals e power 2. And e power 2 is going to be 7.3890. So therefore the answer for the first case is 7.3890, which is the answer present in the option B. So therefore option B is correct. Now coming to the 10th problem. The contour capital C given below is on the complex plane z equals x plus jy, where j is root of minus 1. And they have given the diagram for the closed curve capital C. It is something like a loop which is passing through the origin, and it covers the point z equals 1 and z equals minus 1. That is very important. And a very important observation is the closed curve C covers the point z equals 1 in anti-clockwise direction, which is a positive direction, whereas the same closed curve C covers the point z equals minus 1 in the clockwise direction, which is negative direction. Now we are going to find what is the value of the integration 1 by pi j integration over c dz by z square minus 1. And it is a 2 marks question. Let us see what is the answer for the question. So you are going to take the given integration 1 by pi j integration over c z by dz by z square minus 1. So first of all, you factorize the denominator 1 by pi j integration over c dz by a square minus b square, which is a plus b into a minus b, which is z plus 1 into z minus 1. Now you equate the denominator to 0. You can able to see two singular points, z equal to minus 1 and z equals plus 1, and unfortunately both the points are lies inside C. So therefore we cannot apply Cauchy's integral formula directly, because when I want to apply Cauchy's integral formula, I have to confirm only one factor is present in the denominator of the integration. But whereas in this particular integration there are two factors, unfortunately both the singular points lies inside the given closed curve. Therefore we are going to apply the partial fraction concept. So after applying the partial fraction, I can write 1 by z plus 1 into z minus 1 as minus 1 by 2 into 1 by z plus 1 minus 1 by z minus 1. So which is the partial fraction. And I can take the constant of minus 1 by 2 outside the integration. So we have 1 by pi j into minus 1 by 2 integration over c dz by z plus 1 minus dz by z minus 1. Now you can see the integration is splitted into 2. So therefore here for both the integration minus 1 by 2 pi j is the common factor, and integration over c dz by z plus 1 minus integration over c dz by z minus 1. And we can apply Cauchy's integral formula for each integration separately. So in the first integration your f of z is 1, and in the second integration also your f of z is 1. But in the first integration the singular point minus 1 and the closed curve C covers the point minus 1 in the clockwise direction, which is a negative direction. So therefore I have to include one negative which is missed in the notes. So it is a small change that you have to note down. So it is minus 2 pi j into f1 of minus 1. And for the second one, the closed curve C covers the singular point 1 in the anti-clockwise direction. So no need to change the sign. It is minus 2 pi j into f2 of 1. And we know that the function in the first integration, the numerator of the first integration and the second integration both are 1. So whatever point we are going to substitute, it is going to produce only 1. So therefore the answer is going to be minus 1 by 2 pi j into 2 pi j into minus 2 pi j minus 2 pi j. And you can remove this minus 2 pi j outside. So minus into minus becomes plus, and 2 pi j gets cancelled. So it is 1 plus 1, which is 2. So it is a mistake made in the notes. So you have to correct and write the answer as 2. Coming to the last problem of this particular session, the value of the contour integration 2 pi j 1 by 2 pi j integration over c z plus 1 by z the whole square dz evaluated over the unit circle modulus of z equals 1 is. So again this problem carries 2 marks. So first of all, let me write what is the closed curve given. So the closed curve given is a unit circle with center 0 and radius 1. It is unit circle means radius 1 and the center is given as 0. So modulus of z equals 1. You take the given integration 1 by 2 pi j integration over c z plus 1 by z the whole square into dz, which is equals 1 by 2 pi j integration over c. I can rewrite the given function in the integration by taking LCM. I will get z square plus 1 by z the whole square into dz. Again we can apply the square for the numerator and the denominator separately. So I will get 1 by 2 pi j integration over c z square plus 1 the whole square by z square into dz. Now you look at the denominator carefully. So it is having power 2, and to find the poles or singular point we are going to equate the denominator to 0. So z square equal to 0 gives me z equal to 0 0. So z equal to 0 is a singular point and it is repeated 2 times. So therefore I want to apply Cauchy's integral formula for derivative. So therefore we can compare the given integration with the Cauchy's integral formula for derivative. So which is 1 by 2 pi j integration over c f of z by z minus a whole power n plus 1 into dz. By comparison, my f of z value is z square plus 1 the whole square, and a value is 0 and n plus 1 value is 2. So n value is 1. So, and the answer for the given integration is 2 pi j into f nth derivative at the point a divided by n factorial. Now we can see 1 by 2 pi j and 2 pi j gets cancelled. So we left out with f of f nth derivative of f at the point a divided by n factorial. So it is given f of z is z square plus 1 the whole square. And before applying the Cauchy's integral formula for derivative, let me confirm whether the given singular point, the singular point of the given integration lies inside the circle or outside the circle. So by substituting z value as 0 in the given closed curve, modulus of z equals 1. So clearly modulus of z, which is modulus of 0, which is 0, and 0 is less than 1. So the point lies inside. So we can apply the theorem and get the answer. Okay, now your n value is 1, n plus 1 is 2, n value is 1. So therefore I want to find what is f dash of z. So f of z is z square plus 1 the whole square. So f dash of z is 2 times of z square plus 1 into 2z. So after substituting z value as 0, that is the derivative of the function f at the point 0 is 0. So therefore the answer for the integration is also 0. So therefore the answer for the given integration is 0. So thank you for your listening.